kind of like this. You can't just say, oh, okay, I'll fix that, I'll just delete that, because that would not work, because enter with an argument is actually a different message than enter with no argument. And so if you just deleted that when you run your program, it would crash, and it would say, couldn't send message enter colon when you touch this button, because enter colon means enter with an argument, only for the purpose of the storyboard. We don't say enter colon in our code. That's just something in the storyboard here. So if that happens, you need to right click on here, disconnect the enter colon that happened in there, and then you just recontrol drag. And when you recontrol drag, it's nice, it will kind of let you try and grab onto something. So it's easy to reconnect. Okay. All right, so now we want to actually implement enter here. We want to implement the guts of it. And so we're going to need another property here, which is going to be that internal stack that these numbers are going to go on. And so it's going to be a var, just like this var up here that we created. And I'm going to call it operand stack. That's a good name for it. And it's going to have a type. Its type is going to be an array. And just like in other languages like Java, when you create an array type, you have to specify what kind of thing is in the array. And so I'm going to put doubles in my array. And that's even, you might say, oh, well, we can't enter doubles because these are all integers basically. But if I were to say 3 enter 6 divide, I get 0.5, so then a double would appear. So that's why I'm going to use double. Now, you can see that we've got this error up here again. It says stored property operator in stack does not have initial value, so we have to give this initial value. So I'm going to give it an initial value of an empty array. And so now you're seeing for the first time how you actually create an instance of a class, so or of a data type. And you do that just by specifying the type name and then these parentheses. Now, we haven't talked about initializers. A class or a data structure can have multiple initializers. Some of them might have arguments in here, but most, if it's possible, will allow you to create them with no arguments. And in the case of an array, it's very obvious what to do. No arguments, it just creates an empty array with no elements in it. Now, one thing I want to talk about is this right here, this type. You know, this is kind of annoying that we have to type this and then we just type it right again. And the answer is we don't have to do that, because in Swift is very strongly typed. In other words, all the variables, all the properties are strongly typed, but there's also a lot of type inference. So Swift can infer this type in the exact same way that digit had no type and it inferred it from here. Operand stack, we don't have to specify the type, and it can infer it from here. And if we option click on operand stack, you'll see, indeed, it's figured out that that's an array of double. And in fact, putting the type in here is considered bad form. If it can be inferred, you should let it infer. So, for example, this bool up here, we shouldn't have that either, because false and true can only be bool values. So we're going to take that off as well. Okay. So now, in our operand stack right here, what do we want to do with it? Well, when we press enter, we just want to append. So append, this is actually the first time we're sending an actual message to an object. It looks just like when we accessed a property, right? The dot. And it's just the name of the method that we're trying to invoke in arrays. It's an array method right here called append. And you can see the argument says new element :t. This :t means it has to be of this type, the type of thing that's in the array. So this has to be a double. So that's kind of a problem, because really what I want to append onto my stack is what's up here in this display text. I like to say something along the lines of display.text. Okay, but what type is this? Okay, what type is display.text? No, that's not string. That is an optional. Okay, remember that display.text is an optional. So we can unwrap it, even though that's not going to solve the problem. This is still a string, and you're still seeing an error here. It's saying string is not convertible to double because you're supposed to be putting doubles in this array and putting string. So We have a problem here. We have to somehow convert this string into a double so we can put it on this stack. I'm going to use this opportunity to show you another feature, which are called computed properties. So I'm going to create another property, display value, and it's going to be a double. And what I want this to be equal to is I always want it to be whatever's in this display converted to a double. Okay, and I want to be able to set it or get it. So I want to be able to get the value of this double. I also want to be able to set it as a double and have it turned into text. Well, that kind of property really is tied to some data somewhere else. So I don't ever want to set it equal to some initial value or something. Really, I want it to always be calculated. And we can do that. Instead of saying equal something, you just put curly braces after. And you say get, and we say set. Okay, and inside here, we're going to compute the value of this, which is we're going to convert this display text to a double. And then inside here, someone said display value equals something, and we're going to somehow compute, or not really compute it, but we're going to decide what code we need to put that number that they tried to set the display value to in here. Okay, so let's do the set side first. It's actually a little simpler. Inside this set, there's a magic variable called new value. It's not purple for some reason, but new value, and this is the new value. So if someone says somewhere in our code display value equals 5, this new value will have the 5. And so all I really want to do here is say display text equals the new value, but again, of course, this is an optional string. You can't set it to a double because display value equals 5. This new value is going to be a double. But we know how to convert something to a string by using backslash parentheses. Okay, this is the same thing we did when we printed out our digit up here. We just use the backslash parentheses. It tries to convert this thing inside here, which is a double, into a string, and doubles know how to do that to themselves. And so bingo, we got our display text in there. That's all that's necessary. Also, every time someone sets this display value, then we're clearly not in the middle of typing a number anymore. All right, so we can certainly say that. Right, makes sense. All right, what about the getting? Now, in the getting, all we have to do is return this display value. So to do something to calculate what this display value is here, and then return it. Now, this one, I'm not going to take the time to go through the details here, and actually, I've made an extra credit item that you can do, which requires you to figure out what I'm going to type here using the documentation. But I'm not going to explain it here. But I'm going to use a class. It's called an NS number formatter. I'm actually going to create one. Then I'm going to use a method on it called number from string. And I'm going to give it this string, which is the display values text, unwrapped, of course. The result is actually optional, so I'm going to unwrap that. And then I'm going to get the double value of the thing that I get back. Number gives me this kind of generic number, so I'm going to take it and turn it into a double. So there we go. So you can go in the extra credit and look at that later if you want. But suffice it to say, we now have a property display value that when we set it and get it is going to be setting and getting it as a string here. So that is really convenient, especially for right here where we want to say display value. Okay, so this is a double, no problem. We're appending that onto the operand stack. So let's println our operand stack here. Just so, and we can do the same thing here, operand stack. Okay, and this works because operand stack is an array, and arrays know how to turn themselves into strings. You'll see how they do that in the console in a moment here. So let's go ahead and see if our application is actually putting things on our stack properly here. All right, so let's try here. Let's try 56, enter, and look, the operand stack is 56, that's good. 7, enter. All right, 56 and 7. So you can see that arrays turn themselves into strings by doing open square bracket, and then they turn each of their elements into strings and separated by commas. Another one. Okay, so this is good. So we got our operand stack building here. So all we need to do is have some times and plus and minus buttons, etc. I'm going to put them right here that will operate on these items on the stack. So if I pressed plus right now, it would pull the 7 and the 8 off the stack, add them together, it would be 15, show that 15 here, and it actually would put the 15 back on the stack, so then we'd have 56 and 15 on our stack, and then we could maybe plus those together if we wanted by hitting plus again. All right. Okay. So how are we going to do that? Well, we need to make our buttons here. And I'm going to make the buttons again by copying and pasting a digit button. But this time I know about that problem. So right off the bat, I'm going to right click on it and disconnect append digit. Okay, so now this button sends no messages yet anyway. And then we can put a title on here. So here I'm going to have all my operation buttons use mathematical symbols. So if we go down here to math symbols, see there's a bunch of math symbols here. So let's do times right here. First I'm going to put times right there. And we can wire it up. I'm just going to hold down control and drag out here. We're going to call this action method operate. And because I'm going to have multiple operation buttons and they're all going to send operate, just like I did with append digit, I am going to use the sender. So I'm going to be very careful to change this any object to be button. Okay, do not forget that. Okay, so action, we are going to have a sender UI button, call it operate. Here it is. Nice message doing operate. We can copy and paste this button now, right? We got this one, so let's copy and paste to make some more of these. Start out with 4 of them, let's say. Okay, let's get back our special characters here. All right, so let's make this one be divide. Let's make this one be plus. Make this one be minus. All right. So now we got these buttons, and they're all sending. If we look at this here, they're all sending operate. Okay. Luckily, they're not sending anything except operate, so that's good. And when they send operate, we're going to figure out which one is sending it by same exact way we did above. We're going to say what is the sender's current title, and we're going to unwrap it. So operation here is going to be a string, and it's going to tell us the title of the button, so we know which one to use there. Now, I'm going to show you a control flow operator here in Swift that's very powerful, much more powerful than this operator is in other languages. And also very, very important to Swift. Now, I'm only going to show you the simplest usage of it here, but you're going to see on Monday's demonstration and later in the quarter how important this operator is. But it's switch, okay? And switch looks like switch in other languages like C. You switch on something. In this case, I'm going to switch on this string. This is a string. And then you just specify the case of each thing. So, for example, here, I have a case. Let's do the multiply. All right, so we got multiply case right here. And then we just put the code that we want here for multiply. And we can do that for all the other cases here. So let's copy and paste. And we'll do this be our divide case. And we'll have this be our plus case. And we'll have this be our, oops, let me use this, make sure we're using the same character here, minus case. Okay, yeah, you be a little careful here. You know, this minus is slightly different from this minus, which might be slightly different than the minus you type with the keyboard. So when you're putting the symbols here, you want to use exactly the same symbols here in your case. Now, one thing about switch on Swift, though, is it absolutely requires that you have every case covered. Now, since this is a string, I obviously can't have case of every single string in the universe. That's almost infinite. But luckily, there you can say default and just break out of the switch. Okay, that means if it's not one of these cases, by default, just break out of the switch. You could put code here as well, but breaking out of it is what we want to do in our case. Now, in here, we're just going to put the code for multiply. So what do we need to do for multiply? For the moment, I'm going to comment this out. I'm going to use command slash, which is a really nice feature. You do command slash and then command slash again to uncomment. So it's good for commenting out a block of code real quick, because I just want to focus on times. Now, anytime I press any operator, I probably want to give the user an automatic enter. That's so that 6 enter 3 enter times is the same as 6 enter 3 times. Okay, so 6 enter 3 times is going to do an automatic enter on that 3, because obviously I intend to have 6 and 3 be multiplied in that case. For all of these operations, I'm going to say if the user is in the middle of typing a number, then hit enter for me right here. Okay, so what do we need to do in the specific case of times? Well, really we just want to set our display value. Remember, we have our nice display value down here, and we can do setting as well as getting. So I'm going to set that display value up here equal to multiplying the top 2 things on the stack. So I can actually remove something off our stack. We're representing our stack as an array. Of course, you see our stack is an array. And so a stack is something you push things on, you pop things off. And with an array, we're just going to add something at the end to push something on, and then we'll just remove it from the end to pop it off. So there's a nice array. This is an array, right, after and stack. So there's a nice method called remove last. And if we option click on remove last, you'll see here that it removes an element from the end of the array. Now, it does require count greater than 0. So if our array were empty, if our operand stack were empty, this would crash our program. So let's put a little protective thing here. If the operand stack, there's a nice property here called count on that. If it's greater than or equal to 2, actually, because multiply takes 2 operands, so there better be 2 things on this stack, then we can do this. And so we're going to multiply that by remove the next one. Okay, so here we're just taking the last 2 things off of this stack by removing from the end of the array and just assigning it to the display value. And we probably also want to do an enter here, because if I go 6 enter 3 times, well, I want to then be able to say 9 plus and have it add on to the 6 times 3. So we want an automatic enter here as well. Okay, so that's pretty much all we need to do here. Let's go ahead and run this. See how this works. And so 6 enter, or 3 enter, 6 enter. Now we've got them both on the stack, times, and you can see we put our 18 here. We also put it back on the stack, and we can say 5 times. That put a 5 on the stack, and then multiplied them, took it off. So that's working nicely. Now, what about our other buttons here? We've got to make those work. So let's do that. Now, they do very similar thing here. So one temptation would be to just copy here, let's uncomment these out, and then just paste it repeatedly. So put it there, put it there, put it there, and then just change this times in here, to plus, for example, on this one. But this is pretty messy code. Look at all this incredible amount of duplicated code in here. We really probably wouldn't want to write our code like this. People would think we were terrible programmers, I think, if we did that. Really, what would be nice is if we had could write some kind of function. Maybe we could call it perform operation or something like that. And if the argument to that function, remember that arguments have names, right? Here's the name, and then we have a type. If the argument were something which basically was this little operation in here, okay, or some sort of function that would do this operation. So if this could be some kind of function, that'd be cool. And then maybe we could take this code out of here, put it in here. Oops, let's call it perform, not preform. Perform operation. Put it in here, and instead of doing, multiply here, let's go ahead and we could do this operation somehow like this. Maybe operation, call it like a function with 2 arguments here. Okay, that would be cool because we'd be sharing, this check, we'd be sharing this enter, we'd be sharing the removal of the operator, we'd be sharing setting the display value, we'd be kind of sharing a lot of code here. And then up here, if we could just do something like perform operation and somehow specify multiply as the operation we wanted to do here. And then we wouldn't need all this stuff here, right? So this would be cool. Now, can we do this? Well, yes, the answer is we can. And so types, functions, can be types in Swift, just like any other type. So, we have a double here. Whoops, the double, that's a double. That's a type. You can also have a function type. So how do you specify a function type? Well, multiply, or whatever function I'm going to perform here, this is a function that takes 2 doubles as arguments, and it returns a double. So I can just say, I want operation to be a function that takes 2 doubles and returns a double. So I can just specify that right here. This is a type. Okay, this is a type. It's the type of this argument right here. In fact, you can option click on it and say, yeah, that type is double, takes 2 doubles and returns a double. So it's just as simple as that. So all we need now is a function here called multiply that takes 2 doubles and returns a double that does multiplication. So we could go down here and say, okay, func multiply, and I'll have op1, which is a double, and op2, a double, and it returns a double, and it's just return op1 times op2. Okay, and that worked great. I'm going to comment these back out again so we can see if this actually works. But there's no errors here, right? It seems to work. Multiply seems to be a function that takes a 2 double and returns a double, and that's what this argument here is, and I'm passing it along. It should all work, so let's give it a try. So here we go. This is 6, enter, 54 times. And sure enough, it's working. It's doing that multiplication. Works great. And so what about all of our other cases here? Well, we would just need to take this same piece of code right here and put it for all of them. And of course, we'd need a divide method, so we'd have to come down here. I'm going to copy and paste that and make divide. Wait a second. This is starting to be just as bad as we had before, having to make all these extra functions, multiply and divide and all that. Well, it turns out it's so common to pass functions as arguments in Swift that it allows you to put a function like multiply right in here without having to create a separate function like this. And all you do is you just pick it up. So I'm just going to cut that from down here. I'm going to paste it right in here. Now, the only thing you have to change syntactically when you do that is this curly brace, okay? Instead of being after the declaration of the arguments and the return value, it needs to be before. And so you move the curly brace before, and then where the curly brace was, you're going to put in, the word in. And so that allows us to just, sorry, I'm going to comment these out again so we can get rid of our errors. And we can get rid of function multiply down here. So that allows me to just put that multiply right in here, right in line, right as the argument to this function. And it seems kind of wacky for those of you who have not used programming languages that allow this kind of things. They're called closures. It just basically allows you to put a function right in there. And this, okay, it looks okay. And then we could certainly, now we could copy and paste this and put it here, here and change this and put it here and change this. But it can be even better than this. So we know that Swift is really good at something called type inference, where it can kind of figure out the type of something from the context. And it can do the same thing here, because it's looking at perform operation. It knows you're calling perform operation. It knows this argument is a function that takes 2 doubles and returns a double. So you really don't have to specify all the types in here because it knows all this. So you can actually get rid of all these type declarations right here, even the return. And again, see, no warnings, no errors. It knows that this has to be a double and this has to be a double because it knows you're calling perform operation. So it knows the argument to that is like that. Okay, and you can even make this look a little nicer. We could move this all up onto one line. Really makes that nice for readability here. But we can actually do even better than this. Because Swift knows that perform operations argument returns something, you don't need this return key if your whole implementation is just an expression like this return keyword. You don't need that keyword because it knows this is going to return something. So if this is just an expression, it's going to return it. Okay, so that looks nice. But it's even better than that because Swift does not force you to name these two arguments. If you don't name them, it will use the names $0 and $1, and then if you have more arguments, $2, $3, $4, such that you don't even need this. Okay, so this is a function right here. It takes two doubles, $0 and $1, and returns a double. Now, Swift knows that they're doubles because it knows you're passing them to perform operation. If you were passing this to some other function that took a different kind of function as an argument, these types might be different. But in this case, it knows that that's what it is, and it knows that it returns one, so it knows it's going to return what this calculation is. All right. Now, one more cool syntactic thing you can do is if you have a function like perform operation, and it has an argument, which is a function, like operation here, if this argument is the last argument, okay, so if I had other arguments before it, and this was the last argument, then you can move the function outside the parentheses. So other arguments, if there were other arguments before, they would go in here. But this last argument, which is this operation, gets to go outside the parentheses. And if there are no other arguments, if this is the only argument, you can actually get rid of that. Okay? So we've gotten down to incredibly concise language here, and we can do this exact same deal, of course, with these other form operations. We just need to change the math in here. This one, we're a little careful with the order of operations here. We want to do this because we put the thing that we're dividing by on the stack last, and that's the first thing that comes off the stack. And same thing here, actually, with subtraction, minus $0. Okay, so this is our entire operate, and you can see that it's incredibly concise, very readable. Times is clearly doing this function, and very extensible. If we want to add more functions, we just one-liners here to put more of these binary functions that have two operands. So let's go ahead and make sure this is all working. All right, so 6, enter, 5 times, that's 30, that's good. How about 47 plus, 77, excellent. How about 2 divide, 38.5. We're seeing the floating point number there working. You can see the stack is doing all the right thing. Okay, makes sense. Now I'm going to do one more thing here, which is to add another operation. This is going to be a slightly different operation. So I'm going to copy and paste these operation buttons here. Again, I'm going to make sure they're lined up really nice with as many of these blue lines as I can get. I'm actually going to leave these buttons here because you're going to need them for your homework. But we're going to change this button right down here to be a different operator, which is going to be square root, which is right here. It's the square root operator. All right. And so I'm going to go back here to do square root, and it's just another case, right? Case square root. And maybe I should just be able to use this same mechanism, right? Let's see if that works. Paste that in there. And instead of this subtraction here, let's use the built-in function in Swift to do square root called square root. And we have $0. Looks good. Yeah, we're ready to go. It should just work, right? Oh wait, what's going on here? we have some sort of error. Why? What's the problem? I don't understand. Let's take a look at this. Now, this error is a little hard to understand.